Hello again to the subject geology and geotechnical engineering. Today I'm going to deal with the subject Earth spheres. The Earth spheres will be presented to you in two different presentations videos. This video or today I'm going to deal with the upper spheres of the Earth. Well, the upper spheres of the Earth are four, and they are in different states. The Earth, our planet Earth, is covered by four types of spheres. The first type is the hydrosphere, is the water cover that covering our oceans and also parts of our continents and also the groundwater. And we have the atmosphere, which is a gas, which is in gas state and covering our planet and containing gases near to the Earth surface. The biosphere is the live cover, which can be in plant cover or the botanic cover, and it can be also faunal cover or the animal cover. The lithosphere is a part of the crust of the Earth, the upper part of the crust, which is solid, which is in solid state. So we have the hydrosphere, which is the water cover. We have the atmosphere, which is the gas covering our planet, and we have the biosphere, the life cover, organic matters covering our planet, and we have the lithosphere, is the solid rocks cover and appearing to compose our continent of our planet. The distribution of these spheres is as the following. We have the hydrospheres composes around 70% of the upper spheres. The atmospheres covers 10%, and we have the biospheres composes 15% of our planet, and lastly the lithospheres covering just 5% of our planet. Regarding the hydrosphere is the includes, or it's the sphere that includes water in streams, rivers, wetland, lakes, seas, oceans, frozen glacial ice, and also the underground water, and the part of the water that also composing our or Earth's oil reservoir. The hydrosphere has a circulation, or the water has a circulation at the surface of the Earth. The circulation starts from the surface of the oceans, and the sunlight, when it is hitting the uppermost surface of the oceans, the waters began to evaporate, and this evaporation can evaporated water can condensations happen to it to clouds, and this happens at the near atmospheric space, which can be between 4 to 8 kilometers high, which the temperature are lower than the temperature near to the Earth's surface. So the clouds can give us the fresh water back to the surface of the oceans, or oceans water, and it can also moves to the continental area, and then we have a process called advection of the clouds to be moved by the movement of the winds, of course, due to the different temperature and pressure at the areas covering the oceans water and the areas covering by the continental solid rocks area. So this difference in in temperature and pressure makes the clouds move to the continental areas, and then they can also participate to give fresh water back to the surface of the continent in form of raining and snowing. So this operation or this process happen also at the surface at the continental area. It's also happen at the highlands of the continental area. At the headlands of the continental area, this raining can change to snowing and makes glacial or build the glacials at the high lands. So we have many sources to the water to be circulated at the surface of the earth using a space from the atmosphere. The raining water can be separated in two types. The first types can go and filtration happen to the water through the plant cover of the earth to the groundwater of the earth, where there are some types of reservoir. We call them the water reservoir. If the raining is heavy, then an overload or overflow happen to the water, and this overload or overflow of the water can stream through the streams and the river back to the ocean, and also carrying many materials from the continental area to be deposited at the or in the oceanic basins area. So this flooding or the heavy raining can also participate to give us a type of erosion and transportation or the weathering processes to transport the materials or the earth materials to the oceans, back to the oceans again. So we have these processes, and this circulation happens to the hydrosphere. The other type of Earth sphere is the atmosphere. And the atmosphere, as mentioned before, is the gas covering our planet. The atmosphere in its turn is a mixture of gases, mostly oxygen and nitrogen. It held to the Earth surface by the gravity of the Earth, which is attracting subjects toward the Earth center. The 99% of the concentrated gases are held within the first 30 kilometers up from the Earth surface. The atmosphere itself can be divided into 4 zones. The first zone, which is known or contained oxygen, is the troposphere. The troposphere is separated from the stratosphere, the above sphere, by a zone. We call it the ozone zone, which is composed of all 3 type of oxygen. The ozone zone is very, very important layer covering our planet and avoiding the sun radiation to reach the surface of the Earth. The sun radiation usually contains the ultraviolet spectra, or the sunlight contains the composes of the many spectra. One of them is the ultraviolet spectra, and ultraviolet spectra is it is dangerous if it is reaches the biospheres contains, it will be destroyed. Therefore, the life appearance at our planet is bended and bended to the appearance of the ozone layer at the surface of the Earth. We are going to study and to speak more about the ozone layer when we are going to deal with the geological time scale, especially the Paleozoic and Phanerozoic Aeon and eras. So we have the stratosphere. The stratosphere, we notice that the temperature begins to rise again at the ends parts of the stratosphere. Then we can distinguish that the stratosphere began to appear up as another cover of gases above it, which we call it the mesosphere. The mesosphere is also an important layer or cover because it destroy any type of space objects as a meteorite, for example, a small part of a small size of the meteorite, it can be destroyed there before it reaches the surface of the Earth. And we can say that the troposphere, which is our part of the atmosphere, which it is important to us because it's composed of mostly of oxygen, important for the life form at the surface of the Earth. It is about 30 kilometers thick sphere covering our planet. The other sphere is the biosphere. The biosphere is usually the content, the organic content that covers our planet, and this has been there at early ages of creation of our planet Earth in a very primitive shape as very small bacteria living in the ocean's water. In general, the biosphere is a thin layer near the Earth surface that is inhabited by life. It includes the hydrosphere. A part of the biosphere is including the hydrosphere, which is the marine life in the oceans. The lower part of the atmosphere has been used by the birds, the flying animals, and also the insects that can fly and migrate from a position to position to a position at the surface of the Earth. And we have also the lithosphere is also being used by the organic matters at the surface of the Earth. For example, we have the trees having their root a few meters down below. We have also special types of animals and microorganisms using the upper part of the lithosphere. The plants grow on the Earth's surface with roots penetrating few meters into the surface below the Earth's surface. We have also the biosphere includes the animal and plants life above and under the groundwater, and the biosphere extends a few hundred meters below sea level, usually where sunlight is available. The lithosphere is the uppermost part of the crust, which is solid and cold rock. The lithosphere is also a part of the crust of the Earth, which is also spherical. We are going to study the crust of the Earth when we are dealing with the lower spheres of the Earth. The lithosphere, of course, is a part of another, or there is two parts in the crust, which the upper part, the cold part, the solid part, we call it the lithosphere, composing our continents at the surface of the Earth, and we have the other part below the lithosphere, which is partially melted, and we call it the asthenosphere. So the boundaries between the lithosphere and the asthenospheres has been also distinguished by the seismological waves, and these boundaries we call it usually the Mohorovic boundary. So the lithosphere is the solid outer section of the Earth and covers the surface of the continents from sea level and up to 8 kilometers high, which is represented by the Himalayas mountain chain. And the lithosphere is a relatively cold and rigid section of the Earth, or the upper section of the continental crust. The lithosphere floats on the top of warmer, non-rigid and partially melted materials directly below, which is composing the sphere. We call it the asthenosphere, which is a partially melted rocks at high pressure and temperature, separating the crust of the Earth from the mantle of the Earth, or the upper mantle part of the Earth. The lithosphere is, of course, represented by the continents covering our planet. The continents have also 3.3 billion years. This has been accretion happened to the solid part of the crust, and has been also developed through this time before 3.3 years ago until the last 200 million years ago, that these continents have the shape what we knowing nowadays. So the continents of the Earth are the North American, the South American, we have the Antarctica at the South Pole, and we have the African continent, we have the Eurasia. It is the huge continent here, which is a part, the western part, it is the Europe part, and we have the Asian here at the east part of this continent, and we have the south part of this continent, which is also the Southeast Asia. It is all together is one continent. We call it the Eurasia. We have Australian continent here, and also many islands at the surface of the Earth, which is composed of cold and rigid rocks. The continents are separated from each other by two types of faults, and huge faults in the or break down places at the surface of the crust of the Earth. The first zone, just like we discussed it in the first presentation about the Earth processes, is the separating area, which is usually appears in the oceanic part of the crust, and this separating area represent the places where continents goes apart from each other. So this is the spreading area where the continent is going apart from each other, and there are also many volcanic eruptions built up the reef of this spreading edge and give us new materials adding to the crust of the earth, and also new chemical compounds and elements added to the ocean's water. So we have the spreading area, and we have also this spreading area. Usually we call them the constructive area or built up area of the crust of the earth. There are also subduction zones, which is a destructive area to the crust of the earth, and the subduction zones are also shown in this image. Here is one of them, and we have also a subduction zone starts here from the North Atlantic within the Mediterranean Sea, and also goes around to Himalayan and also to the south places or south position in the eastern part of the Eurasia continent. So here are the suture line where the African continent collided with the Eurasia continent, and as a result of this collision, a huge mountain chains come up from the basins between these two continents, and as a suture line along this line here, there are also many mountain chains. Here in Europe, we call them here in Europe we call them the Alps mountain chains, and when we come near to the border between Iraq and Turkey and the border between Iran and Iraq, there are another type of mountain chains. We call them the Taurus, the first one, and also the Zagros between Iraq and Iran plates. So we have also down to the Himalayas, where the Himalayas social line or the mountain chains representing the collusion area between the Indian continents with the Eurasian continent. All the materials in the basin between these two parts of the continents has been raised up as mountain chains containing different types of rocks, metamorphic rocks, sedimentary rocks, and also igneous rocks. Lastly, I would like to present some conclusion to the subject of today, which is the upper spheres. The first conclusion I would like to present is that our planet is consisting of interactive, integrated, and well-balanced spheres, which means that if changings happen to one of the spheres, this changing can be reflected in another sphere. The changing in the atmosphere or pollution in the atmosphere can also be suffered by the animals on the plants cover, or the biosphere covering our planet Earth, and so on. So changing in one sphere can also be reflected. This changing can be reflected either positively or negatively to the other spheres. Therefore, the they are balanced, they are integrated, they are also interactive spheres. Therefore, it is important to have a knowledge about these spheres whenever we are going to design or to build a engineering structure. The Earth spheres protecting Earth life forms at the surface of the Earth. It is important that builders, engineers, and city planners include the content of Earth upper spheres in the engineering structures design. And atmospheric activities as weathering by wind, for example, if it is storms or hurricanes, winds in very high velocity, must be considered as horizontal loads affecting engineering structures and must not be neglected in the geological or the geotechnical, in the geotechnical calculation for the engineering structures. The hydrostatic effect of the water beneath the Earth surface, under terrain surface, in form of saturated land or ground, and the capillary water rise can impact buildings' foundations by an opposite load direction, and these are the floating load, which we call it the buoyant effect, and we are going also to discuss this load in the coming presentation when we are dealing especially with the geotechnics parameters and principles. The effect must not be neglected in the geotechnical calculations. The microorganism can also have an impact at the or in the building foundations. Therefore, we should find a way to also measure these microorganism attack to the new materials can be also have places at the surface of the or below the earth surface or the ground surface, which is a composition of cement, gravel, sand, and new material, and new construction come there, and the organism should also make an organization to itself and find out what is this thing that coming to the places, and therefore it is important also to protect the foundation of the buildings from the microorganism attack. Well, the lithosphere of the Earth is unstable due to the earthquakes and volcanic eruptions happen to the crust of the Earth. Therefore, it is important to consider using earthquakes resistance elements and a seismic structure to protect the engineering structures. My name is Sabah. I am an engineer geologist, and the next presentation will deal with the Earth lower spheres. I hope that you get some information from this presentation, and I would like to thank you very much for watching this presentation, and please do not forget to give us a thumb up, like, share, subscribe, or click on the bell down there. That will help us to go further with this type of presentations, and please also write your comments to us and write also your questions to us. we will try to answer your questions. Your comments are very important to us because we would like to develop our presentations, the coming presentation, the way that people understand it better. Thank again for watching, and take care.